All right, here is our test review for the polynomial unit. Number 1 says find all solutions. Let's see, following my factoring flowchart of decision making, is there a greatest common factor? No. Is it a binomial, trinomial, or polynomial? It's a binomial. It's cubes. So I think to myself, what is being cubed? X and 3. Square the first, multiply them together, square the last. Same, opposite, always positive. Set each factor equal to 0. So we get x equals 3. Now let's try this one. Is there a greatest common factor? No. It's a trinomial with a1. Is anything multiply to 9 that adds to 3? No. Maybe I can complete the square. Is b even? No. So we got quadratic formula. And simplifying that, I have this imaginary component. So we get our two complex solutions here. All right, B, is there a greatest common factor? Yes, yes there is. I can factor out 4x squared. Okay, now this trinomial, does that have a greatest common factor? It should not, I just took it out. We got a trinomial, a is 1. What multiplies to 6 that adds to negative 5 is going to be negative 2 and negative 3 with x squared. Do these binomials factor more? They do not. So let's set each factor equal to 0. And we're going to solve each factor. Whoop. So x equals 0. X equals plus or minus root 2. And x equals plus or minus root 3. So this answer, these two, and these two. All right, one more time. Is there a greatest common factor? No. It's a binomial, and it's difference of 2 squares. So I'm going to factor that to conjugates. Hey, we can factor again. 9x squared minus 4 is also the difference of 2 squares. Set each factor equal to 0. We'll do this one first. We're going to solve with the square root method. This gives me x is plus or minus 2/3 I. And then our other binomials, we get x is negative 2/3. And from this one, x is positive 2/3. There's 2 answers and 2 answers. All right, number 2. 1 0 of the function is x equals 2. Using division, show that the remainder is 0. Okay, so if x equals 2 is the solution, that means x minus 2 is what I will have to divide by. I'll do some long division. That's a really crooked line. Let me try that again. That's better. If you like box method, you can do box method. All right, here's my first division thought. X to the third divided by x. That's x squared. Multiply it back. X squared times x. X squared times negative 2. And subtract. Bring down. My next division thought, negative 9x divided by x. Negative 9. Multiply it back, negative 9 times x, negative 9 times 2. Subtract, and the remainder is 0. My quotient is x squared minus 9. What does the remainder of 0 tell you about the relationship between f of x and the binomial x minus 2 that we divided by? X minus 2 is a factor of f of x since the remainder is 0. X minus 2 divided evenly. Okay, number 3. Write a polynomial in factored form and standard form. When you write an equation, you need y equals. I think I'm going to need more room. I write too big. All right. Y equals. The leading coefficient is 1. If these are the zeros, it's x minus the root, x minus the root, x minus the root. That is my factored form. So now for standard form, I have to multiply these together. I'm going to choose to multiply these binomials together first. You can box method, you can FOIL, you can distribute. We've got x times x, x times negative 4, negative 1 times x, negative 1 times negative 4. I'm going to combine my like terms. And now for my final multiplication, I am going to use box method. I find that it will organize my work better. Okay, so the binomial is x minus 2, x squared minus 5x plus 4. So you've got x squared times x, negative 5x times x, negative 4 times x squared times negative 2, negative 5x times negative 2, 4 times negative 2. We have our like terms on the diagonals. So our final standard form answer is x to the third minus 7x squared plus 14x minus 8. All right, for B, equation y equals x minus the root, x minus the root, x minus the root. Now, that's kind of silly. You don't have to write all that out. X minus 0 is just x. Minus a negative is plus 8, and then x minus 1. So if you jump right to this factored form as your first step, that is totally fine. Now I'm going to multiply these binomials together. We get x squared plus 7x minus 8. Either show all your work this way with multiplying it out, or you can use box method. And then as my last step, I'm going to distribute that x. And that is our standard form. Now with C, I have a pure imaginary number, and I know imaginary complex roots have to come in conjugate pairs. I need that negative 3i. So now when I write out my factors, whoops. If you're going to write the factors with the imaginary roots, these are the two you have to multiply together first. You have to multiply those two together first. We would get x times x, x times 3i, negative 3i, x, and that is negative 9i squared. Thought I can move that over. So then simplifying that, 3ix, negative 3ix, they add to 0. And then I squared is negative 1, so this term is plus 9. All right, one more set of binomials to multiply. X times x squared, x times 9, 2 times x squared, 2 times 9. This is not in standard form. I have to reorganize my polynomial in standard form. Highest exponent in order down. Okay, number 4, sketch the graph. What is the multiplicity of each 0? All right, well, let's start with that. Negative 2 has a multiplicity of 3, and the root of 1 has a multiplicity of 2. And when I make my graph, I'm going to be precise by labeling my scale. Now I have to think of my end behaviors. The degree of this polynomial is 5. The leading coefficient is positive, so my right end behavior goes to infinity and my left goes to negative infinity. A multiplicity of 3 is an inflection point, that change in concavity. So I draw that, let me make my pen thicker, in 2 pieces to get that nice change in concavity. And then a multiplicity of 2 means we are tangent at the x-axis. Write out the end behaviors. Okay. Odd degree negative leading coefficient is like a line with negative slope. So as x goes to infinity to the right, y goes to negative infinity. And as x goes to negative infinity to the left, y goes to infinity. Odd degree positive leading coefficients, like what we did in 4, like a positive slope line. So as x goes to infinity, y goes to infinity. X goes to negative infinity, y goes to negative infinity. Even degree negative leading coefficient has end behaviors similar to a reflected parabola. So as x goes to infinity, y goes to negative infinity, and x to negative infinity, y still goes negative infinity. Even degree positive leading coefficient is like a parabola at the end. So x goes to infinity, y goes to positive infinity, whoops. X goes to negative infinity, y goes to positive infinity. Number 6, given the graph, complete all the properties. All right, write end behavior. X goes to infinity, y goes to infinity. This is going up. X goes to negative infinity, y goes to infinity, up. Maximum and minimum, you're only listing the y values. The maximum is right here, and that point is labeled 12.25. There are 2 minimums. This y value is 0, and this y value is negative 16.95. The y-intercept is 12. And now we've got increasing and decreasing. These x-intercepts are going to distract me. I'm crossing off those numbers. I do not use them for my increasing and decreasing intervals. If I highlight my graph, this is decreasing, and this part is decreasing. So the way we write that decreasing interval, this piece is every x less than negative 2, because here's negative 2 and smaller. You can use this arrow to help you. And then this part is every x between negative 0.15 and 2.22. These other intervals, other parts of my graph are increasing. So we are increasing when x is between negative 2 to negative 0.15. And then we can use this arrow on the end to help us. It's every x greater than 2.22. All right, divide. Show that the remainder is negative 5. What does the remainder tell you? And evaluate. All right, I'll do box method for this one. So we're dividing by x minus 2. And then we've got x to the third, 2x squared, negative 6x, negative 9. First term comes back. X to the third divided by x. X squared times negative 2. And then we subtract backwards. Or you can think, what has to fill in this diagonal to add to positive 2x? So 2 minus negative 2 is positive 4x squared. Sorry, that should have been x squared. So you can check, if I add these together, do I get that diagonal? Now we divide again. 4x squared divided by x, 4x. Multiply it back. Subtract. Or you can think, what plus negative 8x is negative 6. Divide again. Multiply it back. And the remainder is negative 9 minus negative 4, which is 5. If I want to write out the quotient, so my dividing answer is x squared plus 4x plus 2 plus the remainder over the divisor. So what does the remainder tell you about the relationship? The remainder means that x minus 2 is not a factor of f of x. It does not divide evenly. What is f of 2? The remainder theorem says it would be 5. Okay, Robert needs to make a box to hold paper clips. So let's picture that index card, because we have to write an equation. So this side is 8 by 11, and it says he's cutting out equal side squares of x from each corner. So that means this part that's left is 8 minus 2x. And this part that's left is 11 minus 2x. And if we were to fold this box up, the height would be x. So the volume is the height times the length times the width. All right, so we've got the graph of the volume. Determine the maximum volume and the size of each cutout. Well, here's the max. That is at 60. So that is 60 inches cubed. And the cutout is at 1.5 inches. Congratulations, you are finished your test review.